Yeah. Oh, hopefully he wasn't in any pain when he went. His last word, Excelsior. You know, oh God, that's sad. Oh, that's like a hero dying. Okay. All right. Anyways, let's go ahead and take our mind off it. Let's do happier things. Hey, math. Okay. So let's see here, just a couple things. This is the last week right before we're on vacation. I mean, all we got to do is get to Friday, and then we are home free. We'll have an entire week off. We'll come back, go ahead and get some things taken care of before Christmas. I'm hoping to give you a couple of days in class to go ahead and look over your IA, because coming up on, I believe it's December 13th, yes, is when the rough draft is due. How many people have already started writing your rough draft? Okay, if you have, great. You should absolutely at this point have some kind of data, whether you collected it yourself or from a source. But I want to give you at least a couple of days in class to have some time to work on that, or especially if you have your data and you're just not sure what to do with it, maybe we can look that over and I can give you some pointers on what you could do with it. Okay, so I'll be letting you know exactly when we'll be doing that when we come back. But your test is Thursday. It's going to be over nothing but probability. We're going to go ahead and start the next section today, which is over sig figs, scientific notation. In fact, you might recognize the first part of these notes from the very first week of school. I don't know if you recognize them or not. I did use that first page to introduce sig figs to you. But we're going to talk about them again, okay? And we're going to go ahead and finish up the rest of the notes. And the other two sheets you picked up today, well, that's a probability review, just a bunch of problems I put together to help you in preparation for the exam. So I figure I'd go ahead and give you those today. We'll go ahead and do the lesson today and tomorrow. Then on Wednesday, we'll review the probability. That'll be a really good time right before your test. And then we'll go ahead and move on. In fact, I'm thinking you could probably go ahead and use this review on your test. Okay, so you staple those together. Anything you want to write on that, any notes, any examples, that would be perfectly fine. And then on Friday, we'll kind of wrap things up and go enjoy some turkey and do some other stuff, whatever y'all are going to do. There you go. All right, so we have our next focus activity of the 6 weeks. The hair and eye colors of 150 randomly selected individuals are shown in the table below. All right, so we've got blue, brown, green, blonde, black, brunette, and red. Okay, at a 5% significance level, the critical value for chi-squared is 12.59. Now remember, normally if you were just solving a problem, you'd want to use the table provided in the notes to go ahead and figure out what your critical value is. Remember, it was two things that helped me identify that. Does anybody remember? It's been a while. What's that, Gabby? The difference thing? Degrees of freedom. There we go. The degrees of freedom and the significance level. Typically, we like to go with 5%, but what were the other ones?
1 and 10.
1 and then 10%. Okay. But on a test, the paper exams, they will provide you that number. They're not going to go ahead and provide you the table, and they're definitely not going to require you to memorize that. But we want to see, is there an association between hair color and eye color? So we want to go ahead and figure out our chi-squared calculated value. Are the hair and eye color independent or dependent? And what is the expected value for green eyes and red hair? Again, to the nearest tenth. Okay, so we've looked at how to do these by hand. Why don't we revisit how to do these in the calculator? Because it's always good, to refresh ourselves on these. So I've got my calculator ready. Or actually, I thought I did. I must have shut it down. I apologize. So where do I want to go in order to input this data? Okay, we just want to go to a scratch pad. There you go. Whether you open a document or just go to calculate. Okay, so where do I find that? Okay, the little button next to 9. So this guy right here? Okay. And what am I looking for specifically? We're looking for matrices. Now, what are the dimensions of my contingency table? Okay, it's going to be 3 by 4, so I'm going to have to choose this template right here, the 3 by 3, and I'm going to want to change this to 4. Okay, so 3 by 4. And let's go ahead and plug in all those values. So we have 14, 10, let's see, 21, 5, Then we have 11, 32, 20, 12, and last row 5, 2, 14, and 4. Okay, so here is my contingency table. Now what? Okay, remember we want to store it. Okay, so you hit Control and then your variable button. And remember, we could store it as whatever we wanted. We even got have a little fun with it those couple of days. I think we stored it as Joker, but I'll just store it as X. So if I go ahead and just type X into my calculator and push Enter, it's going to show me that particular matrix. Okay, so now what do I do with X? Okay, so from here we're going to go to Menu, Statistics. Okay, so Stat Test at the very bottom. There you go, and there's 2 chi-squared. We want the two-way test because we have a two-way table that we're looking at. Remember what GOF stands for? Goodness of fit. That is another test. In fact, there are 3 altogether, but we're going to be taking this one. Okay, so what's the matrix we want to use? Well, we want matrix X. And here we go. So let's see here. The degrees of freedom are 6. The chi-squared value is 18 point, what did I say, 10th? So let's say 18.4. Let me come on back over here to my paper. So it's 18.4, and what are we looking for when we're looking for independence? Do we want my chi-squared value to be greater than or less than the critical? We want it to be greater than. Okay, remember, if the calculated is greater than the critical, that means do we accept or reject HO? We reject. We reject the null hypothesis. Okay, that means, what is it? They are dependent. Okay, and I'll just put DEP, dependent. There is some kind of association. Again, here's the thing about chi-squared. We don't exactly know what the nature of the relationship is. We just know there is a relationship. And it would be for us to, looking at our data, say, okay, well, I think this is the relationship, and then try to back it up. Now, if the calculated was less than the critical, then we accept the null hypothesis. That means they are independent. And there you go. So what was the other one? HO was the null hypothesis. H sub 1 was the alternative or alternate hypothesis. Okay. Very good. Very good. Okay. So these are dependent. Okay. Or you could say not independent, or there is an association. Remember, there was a lot of different ways we could go ahead and say that. Now, it says, what's the expected value for green eyes and red hair? Now, they may ask you to do this by hand, so I'm going to go ahead and show you both ways, and then we'll go ahead and bring it up on the calculator since we already have it. So we're looking for green eyes and red hair. Okay, so green eyes and red hair. So I'm looking for this one right here. It'd be in row 3, column 4. So how do I find the expected value for that location?
You add the sums together.
Oh, we don't add.
Oh, you multiply them together.
We multiply them together, and then we divide by the total. Now, we are already told that there were 150 people here. I got the rest of these values if we're looking for them. So 30, 44, 55, 21, and then 50, 75, 25. Okay, well, since we're only interested in green eyes and red hair, okay, what I want to do is take the row and the column totals for that cell. Oops, yes, I just realized what I did, yeah. See, Stanley's got me all messed up, man. Stanley. Okay, anyways. Then we want to go ahead, multiply those two together, and then divide by 150. Okay, so 21 times 25 divided by 150. And let's see here. Control divide. 21 times 25 divided by 150. So I'm getting the expected value to be like 3.5. Okay. All right. Now, we already put everything in the calculator. Let's go ahead and pull that up. Let's say I want to go ahead and get all the expected values at once. How do we do that? Okay, we go to variable, and then we want EXP. We want the expected matrix. So then I'll just go ahead and push enter. And here we go. See, we are in row 3, column 4. And here are the expected values for each of these. Okay. Now, you remember, do we have a problem if any of my expected values are less than 5? Yes. But this one would be okay because remember, there was one little catch to that. As long as the number of cells is still less than 20%, you're still good to go. So this is definitely less than 20%, so we're good. Okay. So I wouldn't have, what was the correction that we used if there was a problem? Started with a Y. And I believe there's a flooring center in here. Yates. Okay. The Yates correction continuity. There we go. Okay, good, good, good. So it's been a while since we looked at one of those, but does anybody have any questions on what we did? Okay. All right. That's what I think I'm going to be doing for a while, is taking the focus activities and using those to kind of spiral back in some material that we haven't seen for quite a while. Really probably focusing more on the calculator aspect of that because, because, trying to get my train of thought here. No, that's my studies. What can you use on both paper 1 and paper 2? Well, you're going to be provided a formula booklet, but you can use a calculator on both of those. So the better you feel about the technology, 1 second. You may. You can use a calculator on both. Yes. Oh, no, no. If there was one of those we weren't allowed to use a calculator, then I would have to spend way more time, showing you guys by hand. But we can kind of save some time here for that. Actually, I should have a hard copy. Yeah, here it is. Okay, there you go, man. Okay. All right, good, 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 good. So you've already got 2 focus activities now. We'll probably go ahead and turn those in a week or so after we get back from Thanksgiving, so go ahead and put that someplace safe. Let's see, the people who are going to take my quiz. All right, Carolina, Camille. Now, you can go ahead and stay in here, or you can go out in the hallway. I'll leave that up to you. The table really only fits 3 people, so. Okay, Sierra. And there you go. Caitlin. And Libby. Here we go. Oops. There we go. Uh-huh. Okay. All right, well, with that out of the way, let's go ahead and talk about some sig fig, scientific notation. And this is one of 2 lessons that's going to get kind of strange because we're going to start talking about rounding errors, how to approximate, things like that. And while it may seem a little odd, this is how we do it. And actually, it's a form of bias when you're looking at your IA. Let me see here. Number set sig figs. Okay. Now, unless anybody has any real questions, you might remember that way back in the first week of school, I went through the classification of real numbers according to IB. Okay. We have what's called cardinal numbers now, remember, instead of the natural numbers. But we still have the hierarchy broken down. Do you guys want me to leave this up here for you to copy in a second? Okay. All right, so the natural numbers are now known as cardinal numbers. Okay, we don't have anything that's listed as whole, so it's slightly different from what you were, taught in your other classes. You're welcome. See, now everything's off today. Wonder if it's too soon, but I hope he got his cameo filmed already for the next movie. And you know that had he, if he has gotten his cameo for the next Marvel movie or the next couple, because I know both Captain Marvel and Avengers 4 come out early next year, right? Or at least by May.
Avengers 4 is in April, I think.
Is it in April? Okay. So I'm hoping that he would have got those done. You know, the round of applause in the audience when he shows up is going to be huge. What's that again?
Far From Home has wrapped already, so he probably got his.
Oh, really? They're already done with the Spider-Man movie. That's next summer? Think so? Okay.
Next July, around there.
Yeah. Wow. And you know, off topic from Stan Lee, but still talking about comic book movies. Did you hear what they did to Wonder Woman? That annoys me. They moved it. It was supposed to come out next November, and they moved it to summer 2020.
Wonder Woman 84?
1984. I know. Now here, and they're at least being honest about it. The sole reason is that because the first Wonder Woman was released during summer, and it did amazing. So they thought, well, they had a slot. One of their other movies got moved for other reasons. So they said, oh, we're going to go ahead and fill that slot with Wonder Woman. See, that's the problem. They shouldn't worry about just trying to make money. If they make movies with characters that people are going to care about, with good stories, the money is going to be there.
Especially
Okay.
Wonder Woman.
Yeah.
It's like the one DC movie, like everybody.
So there you go. There you go. Okay. Sometimes you just have to wonder. I don't know. Ah. All right. Has everybody got that copy? Okay. So I'll probably revisit this from time to time, you know, classifying the numbers. You've done that. Now it's for 2. So if you have a question on that, absolutely let me know. But I want to go ahead and talk to you about sig figs. Do those numbers look familiar?
Yeah.
Do you guys still have this copy? I mean, we'll run through these real fast, and then I've got a whole set of other ones. But does anybody remember the little strategy I used if you were having trouble telling how many sig figs a number has?
Pacific and
Yeah, you remember, okay, instead of trying to draw America, I'm just going to go ahead and put USA right here in the middle. And then we have our coasts. We have the Pacific, and we have the Atlantic, right? Okay, so what did those stand for, the P and the A?
present and absent.
What are we talking about? The decimal. Okay, so think about the decimal. Okay, so obviously you got the point when I first taught it. Decimal. You got the point. Yeah. Yeah, there you go. Okay, so the decimal is either present or the decimal is absent. And what you're going to do, depending on what side you're on, pretend you know that the number is in the very middle, right where you know the United States would be. If there is no decimal, you start counting from the end, the right side, and you start counting at the first non-zero number you have. If the decimal is present, well, then you're going to go ahead and start counting it normally from the front, again, with the first non-zero number that you have. So, for example, 5,032, I'm going to start counting from what side? Okay, from the right. So the very first digit is a 2, so 1, 2, 3, 4. That would be 4 sig figs, 4 significant figures. 2,400. Only 2. See, there's no decimal, so I'm going to start from the right side, and I don't start counting until I hit the first non-zero number. So that only has 2 significant figures, 2 sig figs. 32,007. That would be 5. So if you do have zeros between non-zero values, you do want to go ahead and count those. So this one's 5. 0.000430. That would be 3. It's present, so I'm going to start counting from the front. We start counting at the 4. Now, because it has a 0 at the end, we are going to take that. So that is 3 sig figs, because that 0 is going to be considered a placeholder. Okay. What about the 6.016? That would be 4. And 5,000. That is only 1. Yes. That is only 1 sig fig.
I guess you could say decibel's a pretty significant figure.
All right, and then I got a few others here in case anybody would like to take a look. I mean, we can go through all of them or just a few, whatever you feel comfortable with. These are just some that I pulled up right before you guys got here. So how about, John, how many significant figures would 246.32 have? Now, see, the decimal is there or no? It is there, so I start counting from what side? From the left. And you start counting from the first non-zero number you have. So it would be 5. Okay. Haley, what about 1.008? That would be 4. Okay. Emily, 700,000. 1. No decimal, we would start from the right side. So we got to go through a lot of zeros before we get to that 7. Hillary, 107.854. That would be 6. Are you okay? You're broken up about it too, right? You know what I'm talking about, right? Stan Lee passed away. Oh my God! He's a icon in comics. He's the old man who always makes the cameo in all the Marvel movies.
Oh, I know who that is. I do.
Do you really, or are you just saying?
She just said.
Okay.
I do.
She's gonna walk out of class. I don't know. Okay, come on in. All right, so let's see here. Louise, what about 0.00340? Oh, if you'll just put it in the tray, please. Okay, it is 3, yes. Very, very good. 350.670, Peyton. Okay, 6. I would agree. 100.3, Zoe. Okay, 4. 14.600. Let's see, Sydney. Okay, she says 3. What do you guys think? It would be 5. Because with it present, we start from the left, considering like the Pacific, and any trailing zeros would count. So that would be 5. Hello. Put that in the tray, please. Okay. Karime, what do you think about 1.0000? That 1. That would be 5. Now, if we had just 10,000, then it would be 1. Okay. But with the decimal, those are placeholders. Okay. All right. Let's see. Gabby, what would you say about 0.678? 3. So would this 0 count? No, it's present. We don't start counting until we get to that first non-zero number. So that's 3. Let's see. 0.0001. All right. It is 1. There you go. And last up, 320,001. Who haven't I not talked to? Samir. Okay, he says 6. Is he correct? Yes. Okay. Is everybody starting to get the idea behind sig figs? Okay. Oh, yes, please. All right. And like I said, that's just the way I've always looked at it. Your number's in the middle. Think of it Pacific, Atlantic. The decimal is either present or absent, and you just start counting from that direction. If you have another method, though, or you just able to look at it, perfect. Okay. All right. Well, let's see what we got here. Don't want to do that. Okay, rounding and accuracy of answers. Okay, like I said, this is probably going to look a little strange, but, just kind of hang in there with me. Okay, we're going to practice on this. All right, so it says rounding and accuracy of answers. As a general principle, if you do calculations with numbers that are accurate to, for example, 3 significant figures, the answers should be rounded to the same level of accuracy. Okay, so if it doesn't say what they're saying here, a good rule of thumb, if you're not told what number of significant figures to go ahead and round to, even though IB does really like 3 significant figures, it's usually a good idea to go ahead and stick with the number of significant figures that you began the problem with. Okay, now the back page is going to start to bring this up, but we need to go ahead and use this here. It says a measurement is accurate to plus or minus 1/2 the smallest division of the scale. Okay. A measurement is accurate to plus or minus 1/2 the smallest division of the scale. Okay, so let me go ahead and give you an example of this real quickly, and then we'll come back and perform this operation. On the back of your paper, it makes this statement again, okay, and then it walks you through an example. It said, Rod uses a tape measure with graduations in centimeters to measure his height. What is Rod's height range if he estimates his height to be 188 centimeters? Okay, the tape measure is only accurate to plus or minus 1/2 centimeters, and that's what we're talking about. So if your measurements are given in feet, well then your measurements are only accurate to plus or minus 1/2 feet. If you're given meters, okay, then your measurements are only accurate to plus or minus 1/2 meters. Okay, the unit of measurement is what stays the same. That's what the sentence was telling us just a second ago. Thus, Rod's range is 188 plus or minus 1/2 centimeters. So the following represents the values of Rod's height. So we put his height in the middle. Where did we get these two numbers? There you go. We either added 1/2 centimeter or we subtracted 1/2 centimeter. So 187.5 less than or equal to his height, which is less than 188.5. And what's key here, this does not include the value. It doesn't have equality. And it gives a reason here. Note that the upper bound does not include the value of 188.5, since that would round up to 189. Okay. And there are reasons why we go ahead and do this. Probably the one at the top of the list, is it possible for a person to make a mistake? Yeah, when they're measuring something or when they're weighing something, absolutely. But you're probably thinking, Mr. West, you would never make a mistake because you've never made one in this class. Wow, that was a little bit of grumbling as I went through that one. Okay. But it can not only be human error, is it possible that the measurement tool itself could be broken in some way? Okay, you know, maybe a scale that you're using to weigh is off, whatever the case. In fact, you remember, again, that first week of school when we were talking about bias? This is a form of bias. What did you want to do? Let's say if you completely finish your IA, you've collected all of your data yourself, you get to the end and you suddenly realize you made a mistake in your data, in collecting the data. That's exactly what I would do. Emily says just discuss it in the paper, because that very well could happen. You could bring up this topic of accuracy and go ahead and, you know, allude to that. Say, okay, I realized at the end, this is what the problem was. You know, maybe I made a mistake, or maybe the measurement tool was off by whatever, and that's why I got the results that I did. Okay. I mean, some people, you know, may go back and redo the entire thing. Would anybody in here do that? No? Everybody's like, no, okay. But yeah, as long as you talk about it, yeah, it's going to be perfectly fine. So now with that idea in place, let's go back to this one right here. So it says a rectangular field is measured as 91 meters long and 75 meters wide. Okay, what's the area of the field? Give your answer to the appropriate number of sig figs. So what number of sig figs are we looking at here? Yeah, 2. There you go, because both of our values have 2 significant figures. So again, I know what you're thinking. 91 times 75, you got your answer, boom, the problem's done. Again, you just have to consider the accuracy of the measurements. Okay, so this is how we go ahead and do it. I believe, of course, I have everything laid out, and then when the time comes, I cannot find it. Give me 1 second. Here it is. There we go. All right, so if you go ahead and multiply, let's see, what is it, the 91 by the 75, well, then you're just going to get 6,825 square meters, right? Has anybody already plugged that in your calculator? Okay, but what we're going to go ahead and do is apply this idea to what we have here. We're going to go ahead and do this for both the length and the width. So I'm going to put the length right here, okay, less than or equal to less than, because remember, we don't include the upper boundary. So what would be the lower boundary for the length? What's 91 minus half a meter? So it'd be 90.5, right? Okay. And then, okay, 91.5. See, we subtract the 1/2 unit of measurement, and then we add the 1/2 unit of measurement. Is everybody okay with that? So my length is going to be between these two values in meters. And let's go ahead and do the same thing for the width. So I'm going to put the width here, less than or equal to less than. So 75 minus 0.5, 74.5, and then plus 0.5, 75.5. Okay, so what you're wanting to do is kind of get a range of values here, just as we did, but we want to work with the minimums and we want to work with the maximums. And then there's a couple of things we're going to go ahead and do with these. So if I want to know what's the minimum area that we should be getting, well, I'm going to go ahead and multiply the two minimum values that I have. So I'm going to go ahead and say 90.5 times 74.5. 90.5 times 74.5. And what am I going to get? Okay, there we go. And then I'm going to do the same thing. The maximum I should get, I'm going to go ahead and multiply those together as well. So 91.5 times 71.5. Okay. So I'm getting 6,542.5. Oh, you know, I just made a joke about mine not making any mistakes, and then there you go. Okay. What was it? 91.5? 91.5 times 75.5? There we go. There we go. Because my first thought was, that number's not bigger. It should be bigger. All right. So here's the minimum area. There's the maximum area. So what we're going to go ahead and do to get one answer that incorporates the possibility of this bias, the fact that our values could be off, I'm going to first take the average of these two. Okay, the minimum and the maximum. So we take the average, you know, just by adding them up, and then what? Yeah, so plus equals, okay, equals divided by 2. So I'm going to get 6825.25. Okay, so let me go ahead and write this down. So 6825.25. Okay. And now we want to know, based on the area, what's my range, my possible values for the error that I could have. So we're going to use the same two values, but instead of taking the average, I'm going to subtract them and then divide by 2. This is going to give me plus or minus how far off my answer could possibly be. Okay, so I'm going to go ahead and do this. Again, instead of retyping the whole thing, I'm just going to highlight that previous one. I'm going to go in here and change that plus to a minus. Okay, and then I'm going to go ahead and divide that by 2. Okay. Now, of course, I went ahead. You're going to be taking the positive version because you would always go ahead and subtract with the larger first. So I'm just not going to worry about that negative. So it looks like I've got plus or minus 83. Is that what you guys are getting? Okay. But there is something that I'm forgetting here. The significant figures. Now, this error right here is already in 2 sig figs, but we need to go ahead and rewrite the first value as 2 significant figures. Okay, so don't say it out loud. Take about, I don't know, 15 seconds, 20 seconds if you haven't already done it. I need to rewrite this number, 6,825.25, as just 2 sig figs. Because right now it's how many? It's 6, so we got to get rid of some of those. We want it to be 2 significant figures, just like we started the problem. And if you have to lose the decimal, that should be fine. Okay. In fact, anybody tell me what it should be? 6,800. So 6,800 meters, and then plus meters squared, and then plus or minus 83 square meters. There you go. Okay. Oh, the plus or minus 83? That came from the difference. What I did was I multiplied these two guys together. Okay, so to get the actual answer, I took the average, and then the other one, to get that 83, I subtracted the 2 and then divided by 2. Okay. All right. Questions? Okay. All right, well, let's go ahead and try this one right here. Find the area of the circle of radius 2.33. Okay, so how many significant figures are we starting with? Okay, 3. So we want to make sure that, our answer is in 3 sig figs. Okay. So I'm going to go ahead and set this up for you. So we're talking about the radius here. I'll tell you what, why don't we go ahead? Would someone like to come up and show me this one based on what we did a moment ago? Or do you want a few minutes to try it on your own? Samir, what do you like? Try it on your own. Okay. So let's start there. First thing I'm going to do is create that little compound inequality. And of course, R stands for the radius. Okay. Always thought these kind of problems were fun because I like to work my way around them. Around them. No? Yeah. Yeah. Yeah, I understand. She got it. She just doesn't want it. Okay. Let's at least see if everybody's on the right path. What should my lower boundary be? 1.83. Okay, the 2.33 minus 0.5. Upper boundary? 2.83. What did I mess up? Right. Okay. Make sure. All right. And then now here, see, we're to find the area, of a rectangle, we got to multiply length times width. But what's the area of a circle? Okay. Pi r squared. So I want to go ahead and use these values right here. All right. So let me see if I can get the same thing you guys did. So I like to use pi right down here at the bottom left. Okay. Pi times 1.83 squared. Okay, so the smallest area, I'm getting about 10.52. And then pi, parentheses, what was it, 1.83? Oh, 2. Was it 2? Oh, yes. Okay. Just seeing if you're paying attention, and obviously you were. Okay. Work on that. When I make my jokes about not making a mistake, to not make a mistake. Would really go a lot better. Okay, so here's the maximum area I could have. All right. And then now what am I going to do with the 2? Okay, first I'm going to add them. Okay. So I'm going to go ahead and take this one plus this one. And again, I'm using the values in the calculator. If you want to go ahead and kind of skip a step here, put them in parentheses so that you can go ahead and divide by 2. Divide by 2. There we go. That would be fine. And I think it should give me a decimal, but I'm going to go ahead and put that at the end anyway. All right. So I got 17.8408. Now I'm going to do the exact same thing, but with one difference. Well, I'm still dividing, but I'm going to subtract. Okay. So I'm going to subtract the 2. And this time I made sure that my larger was in front, so I would have a positive. So I'm getting 7.3199. Okay. So what are we talking about here, our unit of measurement? We have centimeters. Okay. So we're looking at 17.84 centimeters squared plus or minus 7.32 square centimeters. But we are forgetting something. Sig figs. Remember, how many did we start the problem with? 3. So what would this one be, the actual area? 17.8. Okay. 17.8 plus or minus, what was it? 7.32. Okay. Centimeters squared plus or minus 7.32 square centimeters. How many people got that right? Okay. Was it just we didn't have enough time? Or is there anything I can do? Hey. No, it really doesn't. Just if you happen to put, like I did, the smaller before the larger in the previous one, just ignore the negative. Because the value itself is going to be correct. Okay. What can I do to help you out? Hey, okay. Some more practice. Oh yeah, I got some more practice. I have a homework sheet, but I also have another sheet of full problems that we're just going to do in class. Yeah. Okay. All right, so I've got 206. Let's go ahead and stop right there. If I can get you to get the calculators up on the